Sir, good morning, everyone. Presentation. My name is Dina. I was number is 720 I'm from Chemical Engineering Department. Today, my seminar topic is nuclear energy. It is a sustainable energy source. Nuclear energy is a main power plant by splitting the nucleus of radioatoms such as uranium. Nuclear energy has the potential to increase renewable power global energy is projected to increase significantly by 2050 years. Nuclear energy currently provides about 10% of global electricity use, approximately 440 reactors. The US and France are among the leading countries that rely on nuclear energy. How nuclear energy works? Nuclear energy works. Several steps are involved. First, nuclear fuel. Nuclear fuel, heavy atoms with the smaller nucleus can release energy. Next, uranium fuel. Uranium fuel is the most useful fuel in nuclear energy or nuclear power plants. One uranium kg is equal to 30,000 million kg of coal equal. And U-235 is the most common fuel. Chain reaction. Heat boils water, creates steam. Turns power. Steam turns carbon, generating power. Types of nuclear reactors. In nuclear power plants, there are only two types of reactions: nuclear fission and nuclear fission. A heavy nucleus, example uranium-235 and platinum-239, split into two smaller nucleus along with some neutrons and a large amount of energy. Here we see the picture clearly. Neutron target nucleus, then use the nucleus divided into neutrons and oxygen products. For example, nuclear power plant, atomic bombs, and nuclear reactors. And nuclear fusion, two light nucleus like deuterium and tritium combine to form a heavy nucleus, release a large amount of energy. Here, deuterium and tritium combine energy and heavy nucleus forming and release large amounts. Example, experimental fusion reactors like ITER and potential future energy sources. Types of nuclear reactors. There are several types of nuclear reactors, and first one is pressurized water reactor (PWR). This is a coolant kept under the high pressure prevent boiling reactor. And the Chengdu reactor use heavy water deuterium and oxide T2O as coolant and moderator. Next, boiling water reactor. The coolant boils directly in the reactor to produce steam. And fast breeder reactor generates more fuel than it consumes using fast neutrons and liquid metals, coolants like sodium. Next example. The benefits of nuclear energy. High energy density, 1 kg uranium is equal to 3 million kg of coal. Low emissions, reduced greenhouse gas emissions, reduced reliance, fewer fossil fuels needed, reliable power, operates 24/7. These are the benefits of nuclear energy. Nuclear power plants are using in the world 10% of generating electricity nowadays. And drawbacks of nuclear energy: high cost, accidents risk, and waste disposal and public is essential. So, advantages of nuclear energy. Nuclear energy use with more research and several types of advantages. Firstly, nuclear plants brings jobs and prosperity to a country, provides the world with the most of its electricity. Not many nuclear have happened. Natural disasters face more damage. Canada has easy access to uranium. It's a economy. Lots of energy is produced from a small amount of uranium. Does not emit carbon dioxide like a greenhouse gas effect. Generating electricity from nuclear energy causes little pollution. The advantages of nuclear energy. Disposing of the nuclear waste is very difficult and needs to be done after a lot of planning by the experts. The radioactive waste takes years to be no longer hazardous. Waste must be stored very carefully for a long time. Storing is a problem. The waste is very dangerous. It is radioactive. Nuclear power plants are very expensive to build. Uranium is not renewable and can lead to environmental problems through mining and processing. Next, risks and challenges. Positive its benefits, nuclear power presents significant risks. This includes the potential for accidents and waste disposal issues. Security and high construction cost also challenges. Accidents. Potential for catastrophic events like Chernobyl and Fukushima. The nuclear accidents for Japan. Waste disposal, long-term storage, and management of radioactive waste. Security risk for proliferation and the potential security threats. High cost, significant initial investment for construction. Managing nuclear waste. Nuclear waste management is crucial. There are options like geological disposal and reprocessing. Long-term storage is also considered. Finding safe, permanent solutions remain a challenge. Geological disposal. Storing waste deep underground in stable geological formations. Reprocessing. Recycling spent fuel to reduce waste value and extract usable materials. Long-term storage, storing waste in secure facilities for extended periods. The nuclear waste disposal packing process in underground and next there is the economy of nuclear or constructions of nuclear power plants picture. Nuclear safety basis of protection. When nuclear accidents during the power plants of accident does not the accident does not the nuclear safety layers of protection. Reactor core design prevents meltdowns. Containment structure prevents radiation releases. Emergency schools main handling accidents. Regulatory oversight. NRC nuclear reactor functions inspections regularly. These are the safety regulations of nuclear power plant and nuclear safety protection. Nuclear energy can affect the economy of you use the type of technology. Yes, it can affect to the economy. To the countries that use this type of energy because the economy raises and becomes successful. But of all the nuclear plant fail from it, it harms as a lot. The cost of these nuclear plants are around $2 billion each. However, many people do not realize the effects to the economy when you use nuclear energy directly for saving, fossil fuels price capping, energy supply security, avoided natural import, enhancing technology, experts, etc., etc. These are the effects of economy. This type of technology we can use. Future of nuclear energy. The future of nuclear energy looks promising, though it also faces challenges and uncertainties with increasing global concerns about climate change, energy security, and sustainability. Nuclear energy is being reconsidered as a part of solutions for meeting the world's growing energy demand. Decarbonization and climate change. Low carbon power, base load power. SMR, smaller modular reactors It is safe, smaller and cheaper, flexible deployment, enhanced safety. Advanced reactor technology, generation I will use some new technology we can develop in nuclear power plants, nuclear fusion, nuclear waste management, economy viability and cost reduction, public perception and political challenges, nuclear in space exploration, global energy transition, geopolitical factors and nuclear proliferation. For the future of nuclear energy. Next. The next slide. World over nuclear energy use, which countries use in nuclear power plants, global nuclear energy landscape. USA, France, China, Russia, the top five countries to know the nuclear energy capacity. These countries are leading to nuclear power plants. China, India, uranium Arab countries, expanding programs. These countries are developing nuclear energy in their countries. France is 70% of nuclear energy release. Nuclear energy is a low carbon, reliable energy source addressing safety and waste disposal is crucial. Advanced technologies and cooperation are key. A diverse strategy will make sure to have a reliable power. Advancements in reactor technology, including SMR, smaller modular reactors, and next generation reactors like IV, hold promise for safer, more efficient, and cost-effective solutions. Moreover, the future of nuclear fusion presents the possibility of virtually limitless clean energy growth. It is still years away from being commercially viable. However, nuclear power today is worldwide provide almost 20% of all electricity generated, 80% generated in US, 69% of US non-carbon electricity generation. More than 100 plants in US non-built since the 1970s. 200 plus plants in the Europe lead plants. About 80% of its power from nuclear. Thank you, sir.